We've already got the formula rearranged, so we don't have to work it out from scratch. We did that in the lectures to show where it came from. But the idea is the formula has been rearranged to solve for n, and it's based on having this new value e, which is the part we're adding and subtracting to the point estimate. So when we say we want the confidence interval to be plus or minus 0.01, that 0.01 is the error term. It's the bit we're adding and subtracting. So in fact our confidence interval would end up with a width of 2e because we've added and we've subtracted. So what is the formula for n? Well, we can see in these slides that it's going to be z squared, so it's the critical value squared, times our population proportion times 1 minus the population proportion, all divided by e squared. If we don't have the true population proportion pi, we use our sample proportion p as an estimate. And you can think of this as like we might do a small study just to get a sample p value to put into this to then work out, well, what size sample should we take for our full study. And that's often a preliminary step in this type of analysis. Once you've identified that it's really just a sample size question, it's a sample size question for proportions, we've already got the z value from the confidence interval. We've got our estimate for pi. We're just going to use the sample proportion p. So at that point we can substitute everything into the formula. Z is 1.96, our sample proportion p is 0.46, and the error term is the bit we're adding and subtracting, 0.01. Do the squaring, finish off the calculation, and we end up with 9,542.5. Now that number represents the absolute minimum that you would need to get your particular error for the confidence interval, so that plus or minus 0.01. If you round down the question, you would end up with a larger error term, so you wouldn't have the accuracy that you wanted. So the trick with these is then just a final step of always round up. So our sample size must be a whole number. It becomes 9,543. So always round up, and I suppose the trickiest thing about these is just making sure that you identify that it's a sample size question and we're still dealing with proportions.